We're going to start to look at some chemical reactions. In this video, we're going to focus in on one of the four types of chemical reactions, and that is going to be double displacement. So a double displacement reaction occurs between two compounds, and these compounds are generally ionic compounds. Now they need to be ionic compounds because we need there to be a metal and a non-metal. So what we've got going on here is we have compound AB and compound CD. Now we need to be able to identify which of those letters are going to be metals, and in ionic compounds, metals always come first. So A is going to be a metal, and C is going to be a metal. Then what's that going to actually occur here is the metals, or the cations, are going to switch anion partners. So A is going to take the place of C, and C is going to take the place of A. So our products are going to be CB and AD. Now we do have to be careful. We can't just write whatever C and B are. We do have to consider that there would be some charges here and some crossing over, and we'd come up perhaps with some subscripts, and then we'd have to go balance. So there are going to be a couple of steps here. We're going to form our products, we're going to balance the equations, and at the end we'll also name things. So there are three signs that a double displacement reaction has occurred. So what these reactions are, it would be, say you're in the lab and you had two solutions, they both look like water, and you pour them together, and you have to observe one of these three outcomes. So the first one, and probably the most common one, is the formation of a precipitate, or a solid. So that is something that would not dissolve in water. For instance, if you ground up chalk and put it into water, it probably wouldn't dissolve. So that means that in theory you could put two chemicals together that would create that chalk compound, and then it would not dissolve in the solution. So that's what precipitate is, a solid that does not dissolve inside of a liquid. There are a couple other signs. The formation of a liquid. This one's hard to observe. In fact, you probably have to do a chemical equation to know that a double displacement reaction has occurred for that formation. And also another sign is the formation of a gas. So you could probably smell that one. Now, just because you put two chemicals together in the lab doesn't mean something's always going to happen. So we can have what's called a no reaction. So if you don't observe one of these three signs, a no reaction or an NR has occurred. Okay, so we're going to take a look at a few examples here. First one we're going to do is we're going to create a balanced chemical equation. So really we have a couple of steps. So the first thing we're going to do is come up with a chemical equation, then we're going to balance it, and then lastly we'll go back and we'll name everything. So here is going to be our first two compounds, NaCl and MgF2. Now I actually want to do something first though. I think I want to dissect these compounds a little bit. So our first compound is made up of a sodium that's +1 and a chlorine that is -1. And remember, these charges, you can look them up simply on the periodic table. Our second compound is made of magnesium that's +2 and fluorine that is -1. So what we're going to be doing here is we are going to be switching around our metals. So we're going to be taking sodium and we're going to be swapping it with magnesium. Now we do need to be careful though here. And what we're actually going to do is, and I'll do this down below, we're going to have sodium now pairing up with the anion of the second compound. So sodium and fluorine are going to go together first, so we can work with that one first. So we've got sodium that's +1 and fluorine that's -1. They each have charges of 1. So that means our first compound is just NaF. Now our second compound is going to be made of, the metal is magnesium, and it's going to pair up with the non-metal of the first compound, which is chlorine. The magnesium, which is the metal, comes first, so we need to write that one first. Remember, the positive charge always comes first. And then we have our chlorine second. So if we want to know how many magnesiums we're going to make, we'll look to the number with chlorine. It comes down and tells us that there are 1 of them. And if we want to know how many chlorines we're going to get for this one, we need to look at the number with the magnesium, which is 2, and it comes down here. So those are our two formulas, NaF and MgCl2. And we can write those both in. It doesn't really matter which order they go in. Whatever, it's a whole beaker of chemicals. So there we go. We have now finished our chemical equation step. Now we need to move on to the balanced part. So our balanced part here, our metals are actually balanced on both sides of our equations to start with. We have 1 sodium, 1 sodium, 1 magnesium, 1 magnesium. So they're actually balanced. But if you look at the anions, they're not balanced. We've got 2 chlorines here, and we have 1 chlorine there. So maybe that's our starting point. So if we want to balance our chlorines, then all we really need to do is we need to put a 2 out front. So now we have 2 chlorines here and 2 chlorines on the right-hand side. Let's not forget additionally that this 2 also applies to the sodium. So now we have 2 sodiums here, and over here we only have 1 sodium. So we do need to put something in front there, and that's going to be a 2. So that balances our sodiums. We now have 2 sodiums on the right-hand side, and that 2 applies to the fluorine. So we have 2 fluorines, and we actually have 2 fluorines on the left-hand side already. And so when that happens, you know you've balanced it properly. The last thing we need to do is just add our names to this one. Let's try another one here. This one is going to be between aluminum chloride and silver nitrate. And to dissect this one, once again, like we did with the last one, our first compound is made up of an aluminum that has a +3 charge and chlorines that have -1 charges. We've got silvers that are +1 and nitrates that are -3. Now, maybe I'll start off by doing this one wrong. If we are just going to switch our aluminum and our silvers with each other, the wrong way to do this would be to say, okay, there's our silver, and then we've got AgCl3 there, and then we've got aluminum with the nitrate. Now, this is incorrect because we have not considered the particular charges of each of these substances that we need to cross over to come up with the actual formula. All we've done is we just carried this 3 along. And when you carry that 3 along, there ends up being no balancing. So that is not the way to do it. The way to do it is what we need to do is look at everything at the bottom and say, okay, what we're going to do is we're going to take aluminum, that's the metal over here, and it's going to pair up with the non-metal of the second substance. So we get Al +3 and NO3 -1. So to figure out how many aluminums we're going to have, well, we got the 1 coming down, so we get 1 aluminum. And then to figure out how many NO3s we are going to get, we're going to look at the number with aluminum. It comes down, and it's going to go outside of a bracket. So we have to put a bracket around this thing, and then a 3 outside. So this tells us that we have 3 aluminum nitrates. Right at the top here, I'm just going to quickly draw what this molecule might look like. It's got 1 aluminum, and then it's got 3 NO3s attached to it. So that's why we have a little bracket with a 3 outside of the bracket. So that's one of our products. That's our first product. Our second product is going to be silver and chlorine. They each have charges of 1. So that should make this nice and easy. 1 of each, AgCl. So there are our 2 products. So we can go ahead and we'll write those 2 in there. Ta-da! And then it's a matter of balancing. Now when I want to go to balance this one, again, it looks like all my metals are balanced, which is fine. We've got 3 chlorines here and 1 chlorine there, so that's one place to start. But frankly, I think I want to start with the nitrates because I've got 3 nitrates on this side, right? 3 of those, and I only have 1 nitrate there. So I think the nitrates are the first thing I'm going to balance. So if I do have 3 on the right-hand side, I better put a 3 in front of that particular compound. So that gives me 3 of these NO3s here. That also now gives me 3 silvers. So on the right-hand side, I'm also going to need a 3 there. So that balances my silvers. And I've got 3 chlorines, and I've got 3 chlorines. So that one is all balanced. I guess the last thing we need to do is just name. So we've got aluminum chloride, we've got silver nitrate, and we have silver chloride and aluminum fluoride. Let's look at one more example here, and this last one is going to be between an iron compound and a sodium compound. And I want to do this one a little differently. In fact, here's what we're going to do. We'll name our compounds to start with. So we've got iron 3 chloride. Remember, iron always needs a Roman numeral. How do we know it's 3? Well, it's like we've uncrossed it. That 3 has come up here. So we're talking about iron 3 chloride. And we've got sodium oxide. How we're going to do this one is we're actually going to switch our names. We're going to create the 2 names of our products to begin with. So let's remember that we are taking iron and we're swapping it with the NAs. So what's going to happen here is technically sodium is going to pair up with chloride, and we're going to make sodium chloride. And our other product, we're going to have iron 3 pairing up with the oxide. So we can write our products being sodium chloride and iron 3 oxide. Now, once we have that, we're going to work backwards from our names and write our formulas in. So our first one is sodium chloride. So sodium has a charge of +1. Chlorine has a charge of -1. We're just going to end up with one of each. Sodium chloride, NaCl. Now, the other one here is a little more complicated. It's got iron with a charge of +3. And if you look up oxygen's charge on the periodic table, it's -2. So we go to do our crossover. How many irons are we going to get? We're going to get 2. And how many oxygens are we going to get? Looks like we're going to end up with 3. So there is our formula. So we have completed our chemical equation at this point. Next thing we want to do is we want to balance this. So we just need to find some atoms that aren't balanced, and there's hardly anything that's balanced here to begin with. In fact, there's nothing that's balanced, and having done many of these in my time, I know this is the compound I think I want to actually start with. So why don't we just start with the iron? We've got 2 irons on the right-hand side, and over on the left-hand side, we only have 1 iron. So we'll stick a 2 in front, and that will balance our irons. So that 2, again, applies to the iron, but it also applies to these chlorines. So we had 3 chlorines to begin with, and now we're multiplying it by 2. So 2 times 3 gives us 6. So we actually have 6 chlorines right here in total. Over on this side, we only have 1. So to balance our chlorines, we need to stick a 6 in front. Now, what has that done to our sodiums? Well, that gives us 6 sodiums here, and on this side we already have 2. So to balance our sodiums, looks like we'll just need a 3 in front. And that gives us 6 sodiums. That also gives us 3 oxygens here. And over here we already have 3. So that one is done, balanced, and everything's named.